Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. We have some absolutely phenomenal guests with us today, Anais and Gal. So I'll let Anais get started and tell you a little bit about herself, and then we'll move to Gal. And then we can get started with our first fact.
Awesome. Thank you so much for having me. My name is Anais Urleis. I am the open source developer advocate at Aqua Security. Aqua Security is a cloud computing security company that focuses on end-to-end security solutions, and I'm focused there on the open source part, specifically a project called Trivi, which is security scanning for all of your developer resources.
Awesome. Gal, your turn.
Hi everyone, happy to be here. I'm Gal, I'm the head of engineering at Hexagon, which was recently acquired by Cisco. So I'm guessing that Cisco needs no introduction. But we are focused on distributed tracing technologies and observability in general to help developers move quickly and solve their problems faster.
Fantastic. That's awesome. Well, it's an absolute pleasure to have you guys. And in no particular order, let's start with the first fact.
Awesome. So I'll go first. And my fact is that distributed tracing has become a commodity. I know it's surprising because I'm assuming that a lot of the people listening haven't used or haven't heard of distributed tracing, but it's currently at the phase where not using distributed tracing is like coding coding on a notepad.
Okay, but what is distributed tracing for those in our audience that haven't heard of it?
That's a good question. So let's start with first discussing microservices, right? I'm hoping that a lot of our listeners have heard of that. We're all moving towards more distributed systems. The systems that we're building are made of several servers, several components that interact with each other, each in charge of their own domain. And as we move to the cloud, it's becoming even more distributed because those components themselves are made of several subcomponents. So you have queues like Kafka or Kinesis or SQS, streams, subs. The system is not just one big server where everything happens, but it's made up of a bunch of different little components. And when you want to troubleshoot something like this, looking at logs like we used to do, it's just not enough because the logs themselves are also distributed. When someone makes a request to your server, it can hop to 10, 20, 30 components within your system. And when something goes wrong, you need to be able to correlate all those pieces together in order to understand what is happening. Distributed tracing solves exactly that. It's basically a distributed log of what happened across your system when the user made a request. Every component says what it did, and a context is propagated, and then the backend that gets all those pieces can correlate it and give you the full picture of what happened when the user made a request to your backend.
Amazing.
So I'm curious to ask, distributed tracing, has that been also a part of systems that were monolithic at one point? Or is that something we're seeing come into systems which have that microservice architecture?
So definitely something relatively new. You would have seen tracing, right, in monolithic applications where you want to do profiling and understand exactly what each function is doing and break down performance bottlenecks. But once the system went distributed, then the tracing had to go distributed as well. So this is really something that is, on the one hand, relatively new, but on the other hand, is maturing really, really fast.
I can add that tracing, like the first time I encountered tracing, which is a long time ago before distributed tracing became a thing, it was in kernel development. Like if you build the Linux kernel or the Windows kernel, you have a lot of small components within the operating system itself, and a lot of time-critical things. Also, like one of the most annoying bugs you get with driver or kernel development is IRQL not less or equal. Like the priority queues of the different parts of the kernel are not aligned, so everything crashes. So tracing which element runs at which points in time and how it passes interactions with other things is critical there. In general, anything where you have small components interacting with one another and communicating and have time-critical aspects, you'll be seeing tracing. Gal, I'm kind of curious what your thought is around the differences between tracing, monitoring, and debugging, because those are terms that probably most developers have heard, but they're kind of used interchangeably, but I don't think they're actually the same. What do you think?
Yeah, that's a really good point. I mean, another term that I want to throw in there, which is like a super new buzzword, is observability, right? Which is like a top umbrella that everyone's saying, I need observability to my system. And what is observability? It's basically saying I want to be able to monitor my system. And when something breaks, I want to be able to debug my system. So those are the two first terms, right? When everything's working fine, I want to be monitored. When something goes wrong, I want to be alerted.
Mm-hmm.
And the second part is when it goes wrong, I want to be able to perform root cause analysis in order to solve the problem as fast as possible. Now,
I was going to ask, where is observability implemented in that case? Is there any best practice for doing so?
So observability is kind of like the umbrella term, right? If you can, it's even a bit more than that. But if you are at the state where when something breaks, you know about it, and you can have an in-depth look into your system to understand why it broke, then you can observe your system. And tracing is just a part of that, right? We're still using logs, we're still using metrics, but it's an important pillar for distributed systems.
I actually experience what it's like when you have a large-scale system, but you don't have tracing, distributed tracing implemented. You just have metrics, you just have logs, and then you are having to do the manual work of filtering through those metrics when something goes wrong and trying to find the root cause of where it started. If several services are down, which service was down first and why was it affected and by what was it affected, right? So if you don't have distributed tracing implemented, it's a lot of manual work that you end up having to do, and it's very cumbersome to go through that process. And that happened to me like 2 years ago when I was working as site reliability engineer, and it was a disaster. So it's exciting for it to become more popular.
I think one of the bugs that most developers dread the most is race conditions and Heisenbergs bugs.
Oh, yeah.
So race conditions in general is when two components are running asynchronously, and sometimes one beats the other, and sometimes the other gets there first. So every time you run the scenario, you get different results just because of the race between them. And Eisenbugs take that a step forward, a step even deeper, by being affected by the fact that you're debugging the system. So now you're attaching a debugger, or you're adding tracing, or you're adding monitoring, and it changes the result of the scenario itself. So that also kind of brings us to the point of when should you have your observability tools? Should they be things that you only add when you need to debug? Should they exist there all the time? Because they also have a cost, right? Because if you're tracing everything or you're logging everything, you're also paying in performance and in memory cost and in actual cost in your cloud billing. What do you think about that?
That's actually like a very hot topic right now, and a kind of an advanced one in observability. One community that is worth to mention here is OpenTelemetry, which is like the standard for exporting and collecting metrics, traces, and logs. And one of the focuses of this community right now is understanding, okay, how can I control the level of data that I'm reporting in production, right? Because I want my agents or my data collection always in production, because I don't want to have to deploy again in order to understand if a bug happened, so I don't lose it or change state. But on the other hand, reporting traces and logs all the time for my entire system on debug level, it's unsustainable. It's too much data to store. It costs too much. So how can we dynamically configure our system to import the level of info that we need at runtime, something this community is focused on? By the way, super cool that it's vendor neutral and you get the ability to get those features or value props without tying yourself to a specific vendor.
I have to say this subject is very close to my heart. Before starting Permit, I started another company called the Rookout, which is a production debugging solution. And it really tries to tackle that problem. I won't go into putting an ad for it now, but just I'd say it's close to my heart. And a question that I tackle there a lot, working with customers and developers in general, is the question of where should you do your debugging? Should it be done in your dev environment? Should it be done in your staging environment? Should you debug in production? I'd love to hear from all of you. What's your take?
So, yeah, I can go. I can go. I mean, like, if you can debug in dev, that's fine, but a lot of the time it just doesn't reproduce. I mean, it's cool to be able to debug in dev. It's useful. You can maybe debug it locally. It's maybe more fast, more convenient. It just sometimes isn't an option. And then what do you do?
Anais, what do you think?
I guess it depends on the life cycle of the service that you want to, that you're looking at. Like a lot of times when you just getting started setting up a service, right, and configuring it properly, that's what you do in your staging and your dev environments. And obviously in your staging environment, you want to imitate what's happening in production as close as possible. So there's a lot of debugging you can do you should be doing at that level before you implement it to production. But then obviously it's very limited what you can do in a fake kind of setup, let's say.
Yeah, I can tell from experience, and I'm sure most of you guys can relate, that, you know, you tested something in one environment and suddenly it just didn't function the way it's supposed to in the next, or just worked completely different. And then you're sitting there pulling your hair out. Why is this happening? So, I mean, if there can be somewhat a solution to almost, I wouldn't say maybe replicate, but somewhat, you know, give engineers the possibility of being able to recreate that kind of system where everything works precisely to the dot, then I think it would help a lot of us out. Just to add another thing while we move on to the next fact is some food for thought. I'm curious to see how we evolve with solutions that are like no code and low code, where we have that distributed tracing come in and we can implement something that's very easy but takes care of that full microservice architecture for us already, so we don't have to do all that dirty work. Anyway, I think it's time to move on to the second fact. So I think that's or. So go for it.
Yeah. So my fact for this episode is that PHP is so bad that even its errors have errors. Sorry, all the PHP and Perl lovers out there, but it's a fact. It's a fact. PHP has been developed by several companies, but one of its biggest leaps was in an Israeli company building the Zend engine for it. And as part of the development process, they've added new tokens to the language. One of them is the double colon token as part of the language. And so they had to give it a name within the framework of the language itself, like a constant name to represent it. So they did a phonetical transcript of the word for double colon in Hebrew, and it's pa'amayim nekudatayim. It literally, there's that string of text built into the language, which is already kind of weird. I really don't understand why they did that. But even if that's not enough, like you have this pa'amayim nekudatayim thing that if you don't know Hebrew, like it's like, what the hell is this crap? Even if that's not enough, they wrote it wrong, because in proper Hebrew, you don't say nekudatayim, you say nekudatayim with an A instead of an O. So even when you get that error that you misplaced that token, that error isn't correct by itself. And I think that says a lot about how we humans build software. So we have things here, like we're still using TCP and IP. Those were invented in the 70s as part of ARPANET. And a lot of things there are still, like the fact that for IP addresses, still a lot of companies are using IPv4. You get only 32 bits for an address. And why? I was actually in a conversation with Vint Cerf, the person that invented this, and it was like, I think this is enough. He asked his boss, do you think that's enough bytes? Yeah, sure, push it in. And those are things that we, till this day, decades later, need to work with and solve technical problems around that. So we always talk about technical debt that we have in our own organization, but what about the technical debt that we have as humanity?
Technologies.
Yeah, you're for a big one here.
I just wonder how it happens if there's a spelling mistake in that word.
So specifically here, it's like there's proper Hebrew and there's like street slang Hebrew.
It's the street slang.
And so, yeah, like the way you talk with when you're like when you're just when you don't speak proper. I'm just a better way to say it.
I'm curious to know what the double colon actually means, because the last time I wrote a piece of PHP code was a few years back. Well, actually, more than a few years back, when I wrote an authentication solution for my sister's company. So, what is this double colon? What's the actual meaning of it?
I honestly don't remember. I think it's like when you nest, like you define a scope for objects. There's not a lot of object-oriented programming in PHP, but if you define scopes for things, I think that's how you do it. It's kind of like in C or in C++ more correctly.
Yeah, I'm to be honest, I'm not surprised.
Scopes.
I don't know. I don't know if many people like PHP these days, or actually use it.
It's very popular in Germany still. There are lots of organizations that use PHP.
Yeah, but is it popular because it's legacy, or is it popular because people love it?
No, exactly. It's just not popular. It's just widely used, right? I think that's the right way of describing it. Yeah.
Oh, interesting.
Yeah. You still have like huge companies like Facebook. So they use Hack. That's the language that they use, but it's just a derivative of PHP. It's mostly PHP behind the scenes. And it's still, I'm not sure what the percentages are, but a huge portion of all of Facebook or Meta code base, and that's a huge company still running very significant services that a lot of people use for now until they'll continue seeking with this metaverse kind of thing.
I think Booking as well, by the way.
Booking.com?
Yeah, a lot of companies do. Actually, I'll let that be a teaser for my fact, which is going to come last, because I'm actually going to talk about some interesting things about. No spoilers, though. You gotta wait.
No spoilers. So, what do you think about the technical debt? Like how? So we like within each company, we usually have like a plan. Okay, we'll allocate 10% of the next sprint to minimize our technical debt. Who's saying this for humanity? Who's coming in and fixing the technical debt for all of us? Is there anything we can do about this?
That's a good question. I mean, you can see like, and I'm talking about Cisco, but not because I know anything about it. It's very far away from where I'm located at Cisco, but Cisco is pushing IPv6 exactly because of the reasons that you mentioned, right? There's not enough address space, and they've been at it for like 20 years. It's hard to change the world.
But you mentioned Cisco. So Cisco has a lot of challenging problems because it's also still a lot of things there are kind of connected to the physical space.
Yeah.
You have a lot of these physical routers and hubs and network components. And like I remember I had a conversation with the CTO of Cisco, and eBPF is still a hot trend, but it was just coming out at that point. And I was like, hey, what do you think about eBPF? It's very cool. It's very performant. It gives you a lot of abilities with network shaping. And he was like, I wish all of our competitors would use eBPF. It's so slow. And then I realized, like, I'm coming from the software perspective. So from the software perspective, eBPF is very fast. But where you're coming from the hardware perspective, it's super slow. And there's also like different time frames from changing things. So changing things in software is very fast. Changing anything in hardware, like you actually need to send someone physically with a box into a place and rewire things.
And it's much more expensive. It's not like just deploying a new version to your cloud provider. It's going to the Bezeq center of routers, changing all the core routers from, SDH to MPLS. That's like, a 20 years project.
Yeah. Best case scenario, I'd say even. I think maybe the best thing we can hope for is like when we all upload ourselves to the cloud, where everything is software, and then we'll just run everything in a simulation, and then we upgrade the simulation, and so the hardware is actually software. I don't know.
But what happens if the software that we get has a lot of technical debt? Well, that's going to cause a problem for us, right?
So you just create more software inside of that and forget.
Okay. We'll let the robots deal with that.
Simulation. That's why we know that we live in a simulation, right? Because statistically, if you know this argument.
No.
It's just, I love how you go from one thing from PHP to living in a simulation. Where is this going?
The only reason to explain the existence of something like PHP is if we exist in a simulation. Otherwise, I don't know.
That was not what planned.
You can't just throw this out there and not elaborate on it.
Okay, I'll leave it there. Actually, you know what? I'll save it for another episode. So,
yes.
Listeners, stay tuned. I'll come back with the simulation hypothesis in another episode.
I'm looking forward to it. And without any further ado, I think it's time to get our third fact from Anais.
Awesome. Okay, so my fact is that around 90% of organizations are vulnerable to security breaches due to cloud misconfiguration. And basically, the data shows that around 2018 and 2019, cloud misconfiguration breaches costs companies almost $5 trillion.
$5 trillion.
That's a big number.
Like, think about the number 5 trillion, just as a combined cost for all of your
Wait, how many
data.
How many zeros is that? Is that 9 zeros?
No,
that's
like
that's 12
more than
that's
billion.
like
Oh, wow.
It's like 12, right?
Okay, that's a lot.
Mhm.
That's a lot of zeros.
That's like more than the U.S. spends in a year, right? Like I have I don't know what to reference this to. This number's too
No,
big.
I think it's more comparable with the U.S. like defense budget.
Yeah.
How much is that?
It's probably in the trillions as
I
well,
should
I
have
assume.
looked up a comparison kind of to visualize that better. I guess it's also it's a number that you can't really define that, right? Because of a lot of misconfiguration costs, for example, the additional skills that are required to fix misconfiguration, even if nobody learned about that, right? Anything that goes into spending more on fixing configuration issues in your infrastructure contributes to that, right? So it's obviously it's a rough number of like, this is kind of the estimate that we can come up with to visualize how much of an issue misconfiguration in our infrastructure actually is.
So, first of all, compared to the U.S. budget, the defense budget is a little over 1 trillion. So it's 5 times more than the biggest military force on the planet, which says a lot. We could have built a huge army and conquered the galaxy by now.
Could have.
Yeah. So when you say configuration breaches, misconfigurations that lead to breaches, like what does that entail? What are those like the security components themselves? Is it the containers? Is it the software? What does this encompass?
So it really encompasses everything that is related to you setting up anything that's related to your application, to your deployment, to your infrastructure. In misconfigurations are found in your application when you start developing it, right? Anything that is not configured as it should be. And then from there to you actually packaging up your application and deploying it in whatever format you choose to deploy it. And parallel to that, you setting up your infrastructure, whether that's bare metal or that's a cloud provider. There are so misconfigurations that people put into AWS services, which is just insane because, I mean, it's a very complex environment. Those are very complex tools, and most people don't really understand the different configurations that you can put up. They choose the default configurations, and they are also misconfigured, like not the ideal thing that you should be doing. So by default, you will have likely misconfigurations.
So if I'm a individual contributor, just a developer, hands-on, what can I do about this? Because obviously there are tools that you can adopt. There's security policies that you can apply. But as an individual contributor, it's kind of hard to apply this on top of everything. So aside from going to my managers and saying, hey, this is going to hurt us down the road, what can I do as an individual
right now?
Yeah.
Like maybe like some best practices or something like that.
I think the first issue, what you mentioned, is that you want to apply it on top of everything to fix your misconfigurations. And that's already when you will have misconfigurations that you won't find when you choose to apply security scanning and identify misconfigurations on top of doing everything else. So that's what a lot of companies do. They have a security team in place, and they're the sole single point of failure of checking that everything is running like it's supposed to. and they obviously can't catch everything, and they don't know the application or your part of the application inside out. So there's by default going to be something that they're going to miss. So what you can do as an individual contributor is look at every single asset that you're using, every single resource, and check the best practices for how you should set up those resources, right? Like there are companies that are writing about misconfigurations or like best practices around different resources, different tools. There are individual security researchers, right, who write reports. There's university research. There's obviously lots of information, and there's an overwhelming amount of information out there that you could reference. If you don't want to do that, if you don't want to put the effort in, there are lots of different security scanners that can scan your resources and tell you the common misconfigurations of like, they can't tell you, are you following really best practices and is your application like set up nicely, but they can identify major issues and tell you you should configure XYZ differently.
So I have a follow-up question for you, and it might be a little bit broad, but I'd like you to take a shot at it. When we talk about cloud misconfiguration, at what point does it actually start becoming dangerous? Like, what has to happen for it to be, marked as something's wrong? We did something wrong. Like I know it's very broad, but like how do we recognize that? And maybe is there any mechanisms that help us see it before it happens?
It's a great question. It will really depend on your resources and on your infrastructure. I think when something goes really, really wrong is when...
we panic and we cry.
The thing is, you won't know when you're supposed to cry, right? That's the main issue. You don't know when you're... afterwards that you were supposed to cry, but you...
You just brace yourself before and you already start crying.
Yeah, your tissues 24/7. That's the best strategy. No, obviously I think the main, when it becomes really critical is when any customer information are potentially being exposed, because ultimately your customers, they trust you that you set things up properly, right? The thing is that companies obviously don't have to set up things properly in their infrastructure and application configuration to sell you the service, right? They can just go ahead and sell you the service and you don't know how. It's like buying a house, right? Like you don't, unless you do like a structural survey of your house, you don't know what's wrong with the electricity or like, I don't know, anything that's the structure of the house, the frame itself, right? You won't know that necessarily.
Right.
And that's similar to you using an application. You won't know what's wrong under the hood until your data is out there. And there are lots of, I think one of the best examples that are used like across different magazines and like reporters and so on is really like dating app data that has leaked and other sensitive data like that. And it's very embarrassing for people if something like this is out there, right? So I think that's like the most critical point that you want to prevent at all costs, is that the database of your customers is just exposed to everybody. Or accessible. And things you can do is you can pay for specialists to do things like chaos engineering, test your, try to get access to those resources and mess with your system in ways that you wouldn't expect, in ways that people internal to your company, to your team couldn't be doing. But that's like the secondary thing. The first thing that you should do on a day-to-day basis is look at those best practices that you can implement.
I'd like to add to that. So we've kind of, first of all, I think there are some great tools that are worth mentioning. So there's Treevee from Aqua, and there's we had Shimon from The Tree on another episode. And there are a bunch of cool tools around there. So there's definitely things that you can do to have kind of a safety net to try and catch if you've done these mistakes. It still would be very hard. There's the cascading effect. You don't know which little thing is going to break the entire aspect, because when an attacker comes in, they'll try the smallest of holes to get gradual access into things. But I think another maybe good suggestion is just have less things. The less you build and the less you configure, the less room you have for errors. And especially with critical services, it might be better to delegate that work to someone who specializes in building that service. Obviously, there can also be vulnerabilities on that side, but it's a risk management kind of thing. And if you maybe it's about finding the right balance of what you know best and how you can focus on getting the configuration there as right as possible, as opposed to other things that you're not as good at.
Yeah, and maybe another thing that I like here, at least in young startups, is that like, oh, we're on the cloud and AWS takes care of it for us and it's secure, right?
Right.
And then I think back on like how many times it's actually the cloud provider makes it really hard to be secure. I remember when we started in Epsagon, we started using Lambda heavily.
Mm-hmm.
So we had an RDS, and the best practice is, of course, put it in a VPC, no internet access, allow only the computer users to access it.
Mm-hmm.
And then all of our compute was on Lambda. And Lambda had like a cold start of 40 minutes on a VPC at that time. So we couldn't really, like, these Lego blocks didn't fit together.
Yeah.
So if you're going to say, yeah, my cloud provider is going to take care of me, like, that's, don't do that.
It's also a comment on if you want to be at the regular edge, cutting edge, bleeding edge. That also brings some security risk and friction that we don't necessarily always think about. I think this is a good point to move to our fourth fact, and I think that fact is yours, Philip.
That is mine, and I've got a pretty light one for you, but it's actually quite interesting. And my fact is that there is 350 programming languages currently counted up to date. Actually, there might be a little more than that. Now, to give you an interesting comparison, the country in the world who has most spoken languages is Papua New Guinea, with 836 languages.
Wow.
And then comes Indonesia with 710. Now, if you actually compare it, like that's a lot of languages in the programming world. It almost kind of competes.
So you're saying that there's not enough programming languages?
Oh, I mean, but I don't know if we want to go there, because that's just going to make it even more difficult for us and probably give a lot of developers anxiety because they want to know, as many as they can. But the question here is there enough languages? Will we need more? Will it continue evolving? There is a lot of also dilemma between how many languages maybe someone should know, which ones you should use. It's a big topic, so I'm curious to hear opinions, and then I'll share and go back to a previous conversation that we touched upon earlier.
The inverse question would be, are there too many languages? And we should maybe reduce the number that we are dealing with.
Yeah. I definitely think, I don't know about the amount, I definitely think there are specific languages that we can remove.
PHP.
You said it.
All the PHP listeners are just going to quit right now.
No, they're going to send me a DM on LinkedIn or on Twitter. You pitiful fool, you don't know it's such a great language. I'd love to have it. Please DM me. I want those messages. I'm Orwise, ORWEIS, across the space.
I've actually had an incident, not an incident, and I don't know how to call it, an event with one of my developers where he was writing, we are coding in Go now, and he was writing a lot of, and I was trying to like do a PR, and I'm a C developer in my background.
Mm-hmm.
And so I saw that something was passed by a ref and not by value, and I was concerned that like it won't be in C, if you allocate something, you have to deallocate it, and it's your responsibility. And, I changed something, and then he said like, oh, don't worry about it. Go just takes care of it for you. Like it will be taken care of when it's time. And it kind of blew my mind, right? In the sense that, okay, I'm very happy that someone came up with Go, because if I had to write that in C, it would have been much harder. But then there's another discussion of, should we retire all languages? Like, does C have any advantages on top of Go today?
Right.
It's still more performant. Like you can get better performance out of it, and it's still hard to compile things in Go for like the kernel and stuff like that. It's technically feasible. I think it's easier with Rust. Rust also tries to take away pointer manipulation and memory manipulation, or at least make it easier. But it has I think better advantages in compiling for drivers and stuff like that. But also it's it's a matter of trust. Like, do you trust your engineers to release their resources? Do you trust them to apply the right best practices with the code? There's always like this tension between how much power you have and how much trust you get. Or as Spider-Man's uncle put it, with great power comes great responsibility. So with great pointer and memory liberty comes a lot of responsibility.
I think it's actually quite hard to retire a language or to get rid of one. And I'll give you an example. The engineers at NASA, they were using two programming languages to kind of control the International Space Stations. One was pre-2005, and there was a language released called ADA, which was developed in 1980, and it's essentially accepted as the international standard programming language as of today even, for all astronauts who go into space and they need to manipulate the International Space Station. Now, that's a really old language. That's what, right now, 43 years old, and they still have the requirement to learn it. Tiring languages, there's a lot of things that you need to cover, especially if you have so much software that was written in it. Well, you'd have to rewrite it, or maybe not. What do you think?
Replace
I think it's really hard. And also makes me think of COBOL. Like a lot of mainframe systems for banks and other kind of government institutes are built on top of COBOL-based frameworks, and I think COBOL is even older. Things like from the 70s almost. And it's, by the way, it's a great way to make money. If you know COBOL, there's very few engineers that know that, and they still need to maintain those systems. They pay a lot for just maintenance for that. In the end of the day, there's this one server that was set up in like 1960. It's all dusty, and there's like just one guy named Dave. He's the only one that knows how to operate it. And it's really hard to change it. Also, it hurts the job security of those people. So there's also tension to not upgrade. I definitely think that we should, but again, I think the only solution would be to go into a deeper simulation.
That's really challenging, by the way, for engineering leaders to, when you have tech debt or when you have old technology and you have to go to your the first layer of non-engineering manager and convince them that you need to implement effort because in 5 years from now, no one will know this language or it'll be problematic to maintain the system. That's like always a very hard discussion.
It's also hard the other way around, because you go in, oh, there's this cool new language. There's Go, there's Rust, there's Dart. Oh, I want to try it. And like the other person, like, is this going to be out of support in like a year or two? Is this just a fad? And then we'll have to rewrite everything.
I just wanted to add that, for example, because Rust was mentioned earlier, that when I got started in the cryptocurrency space in my career, that was the previous industry I was working at. Rust became very popular there across different blockchain projects, open source blockchain projects. And at the time, they had problems finding people, like the companies I was working at, who knew how to use Rust and had experience with it as well, because it was so new at the time and had such a tight-knit but really incredible community, but just really small. And now it kind of spilled over to the cloud space, to cloud engineering and developing distributed applications not for blockchain purposes. So in that way, you saw kind of the effect of like, okay, how can a new language kind of grow and gain popularity? But it could have equally been the inverse, that it just kind of stayed a small community in a very niche kind of industry.
Yeah, for sure. It's kind of interesting to see how things evolve and roll between things, and it makes you think, should languages be specialized for specific cases? So for example, we work a lot in Permit with a language called Rego, which is a policy language that is focused on one specific thing. But a lot of people have hard times adopting that language because, for one reason, it only exists within that space. So it makes you think maybe it would have gotten more popular if it had broader use. And maybe there are also cases where it's the other way around.
What's like so special about Rego? What's the one thing that it does well?
So Rego is a derivative of Datalog, which in turn is a derivative of Prolog. So it's a logical programming language. So it's not like Python or Java or Rust or Go. It's a recursive engine. So you write rules and the engine runs between the rules for you. So it's really good to build things that are rule-based. And specifically, Rego has a lot of built-ins into the language to help with authorization. So parsing a JSON web token, verifying certificates, building structures that are good for implementing roles or attributes and then comparing them, creating allow and deny rules, those kind of things. They're not a very significant change in the language. Like if you know Datalog or Prolog, you're like, oh yeah, I know this crap. But most people don't even know those.
Yeah.
And when you add the specific flavors for authorization, it really becomes something that it can be even a little overwhelming, even if you are a good engineer with experience.
Yeah, that's interesting. Like, is it worth shifting to a language like with a completely different coding paradigm than we're used to, like Python or Node? Like, does the advantages outweigh the cost? Like from your experience?
So, well, I'm kind of biased. So our solution is in Permit, we give you something that generates that code for you.
Oh.
So, and I think in general, there are ways to balance this. The more tools, the more interconnected things become, and the more we bring in low-code interfaces, the more we bring in artificial intelligence to kind of bridge the gaps, I think the problem would be easier. But I still think that the best solution would be to go into a deeper simulation, and I'll see you guys there.
It was an absolute pleasure hosting Anais and Galovas today. Thank you guys for joining. Thank you for your time, and thank you for sharing your awesome facts. And we'll see you guys in the next episode where we share other 4 new facts with you. So stay tuned.
Bye, everyone.
Bye.
Thank you, everyone.
Bye.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.